Hello everyone, welcome to my channel. So in this video I will talk about how you can build a sequence model to predict runs by a cricket player. So here for this example I have used the data ball by data from Quicksheet. Now to get this data, what you need to do, you can directly go to that quicksheet.org/downloads. Then you can just scroll down to the below and you can see like different leagues, different international matches, or all over the match, all over all matches, all test matches, all one-day internationals are there. So you can download the CSV file from here and use it. So coming to the model part, I have used LSTM. So if you are from a data science background, you know like LSTM means long short-term memory. So why I used LSTM? Because first thing is it is one of the advanced architecture to build sequence model, and second is I want to give two kind of input to my model. So the first one is like how the recent form of the player, the past sequence of runs in the recent matches, and also some match characteristics like what is the opposition, what is the innings, like first innings or second innings, the batting order of the player, if it is predefined like Virat Kohli will bat at number 3, and if it is a home match or away match. So coming to the data loading part, so when I downloaded this entire folder from Quicksheet, so here are multiple files. You can see there are more than there are thousands of files. So what I did, I used a function. So it will read all the files from that folder except that the info files, which is not a ball by ball data file. So and it will merge everything and output it as a merge data.csv, so I don't have to read that all the files and merge them again and again. So you can see it is a very long data because it has data from 2003-4. Okay, and you can see like these are the column names, the match date id is the match unique id, the session is the what year, then start date, match date, then venue, innings, first innings or second innings. Okay, then ball by ball information. So ball, the batting team, bowling team, and some other columns like extras, different type of extras. So you can see like from 2003-4 up to 2023-2014. So all the data are all the match data are present, and that's why it has 15 lakhs of rows. So these are the all unique team present, and one thing to remember, this is combination of both men's and women's game. Okay, so I have only filtered out the relevant teams for to reduce the data a bit. So it is reduced from 15 lakhs to 12.1 lakh. So I can directly apply the filter here to my desired player Virat Kohli in this case, but I kept it all this because I want to keep the code as much as constant. So if I just need to change the player name and it will done everything. And also I want to compare few things like how the batting order affecting runs, etc. Okay, now coming to the part, so it was a ball by ball information, so I used this group by then some transform some function. So I have created a new column named total runs. So what it does is actually it will aggregate all the runs and add in this column. So in this particular match, so David Warner scored total 7 runs, and suppose he played 20 balls, so all the 20 rows will get this value 7. Okay, so as soon as I get this match information, so first I delete this runs of bat column, and you can see for one particular match, rest of the columns are unique, have unique value. So I just deduplicate it. So now my entire data set is converted from ball by ball to match by match, and you can see like it, those are reduced from 12 lakhs to around 40,000. Okay, now if I check the top 10 rows of the match, and you can see it will literally get a scorecard of a inning. So starting from David Warner 7 to up to Mitchell Stark 10. Now when I looked at these venue columns, there are around 300 venues. So it is not manually possible to convert them to its country. And why I want to convert it to the country? Because this much of unique values will not get any meaningful information in my model. So I want to reduce these categories so that I can one hot encode those and generate some meaningful information. So here I used actually ChatGPT. So in the basics of ChatGPT, like I just give the name of list of all the venues, and I tell him to use your own knowledge to classify them in those international countries like Australia, India, England, and all. So you can see it has group mapped all the venues to its respective country. Even they converted West Indies also and some small countries also. So if I scroll down, you can see these are the unique country names, and there are some uncommon countries. Okay, so I just converted them to others to reduce the categories further, because only this much of values is not make much sense. Now here I added another column named home. Okay, so it is a home match or away match. So wherever venue is equal to batting team, because I am working with the batting data, so it is 1 means home and 0 means away. And for the neutral venues, it will also consider is away for both the teams. Okay, so there are some data where innings is greater than 2, so these are basically super overs, so I filtered out those as well. Now I wanted to see like if batting orders makes any impact. So here I actually created another column named batting order. So for 0 and 1, both will be considered as opening, and 2 means 1 down, 3 means 2 means 1 down, 3 means 2 down, 4 means 3 down. And it will adjust at the cumulative count of it to get this batting order number. And here 0 and 1 both is converted to 1 to means it is opening. Okay, now if I check that total runs for across different batting order, you can see like top one, two, three are almost same and very less difference. But from four, that is three down, it is going to dip sharply because many matches are also players are not out or don't even get chance to bat much. So we need to consider all of those things, because when we are predicting anything, it is our goal is to minimize that average error. And so I need to consider both the conditions, when the batsman is getting total bat and when getting very less bat and remain not out. And also, as the batting order goes down, the quality of players usually reduces. So here is just a plot that I created to see like across home and away how the average run across different batting order varies. So the home is obviously slightly above the entire graph, so you can see like home team usually performs well. And here I plotted similar graph across different batting team. And here I one thing I noticed, like you can see that India number two, that is one down, is the maximum. That is probably the high batting average of Virat Kohli. Here I added another column innings number. So basically, it will add another it will does another cumulative work. So from that very beginning to the end, so it is already sorted by start date. So it will add for that particular player. It will add innings, count the innings from 1 to n. So basically, the first innings is 1, and we play total n innings. So the last rows will be n. And you can check like here I filtered out Virat Kohli, and you can see like the first row starting from that series is debuted against Sri Lanka. And in the recent, he the last match is the India versus Australia, that is the World Cup final. He scored 54. Before that, two centuries against New Zealand, South Africa, followed by 188 against Sri Lanka. So here I am coming to the model building part. So here how the data looks like. Okay, for across his career. Now one thing to tell about like this cricket match performance data is don't have a definite trend. Okay, like one match the player scored 0 and then next match he can score 100. So you cannot get very smooth prediction curve across all that validation and that actual validation set and that actual prediction. But if you just take the sum of the small windows, like in average of 5 matches and all, probably you will get somehow smoother curve. Okay, now here I divided my feature columns in two parts. So these are my numeric columns, and they're mostly Boolean columns only. And there is only the batting order is 1 to 10. Innings is only 1 and 2, and home is 0 and 1. That categorical column is the venue and the bowling team. Okay, so these two need to be dummy encoded, and the target is the total runs. So here I dummy encoded this categorical columns by one hot encoding, and here I merged the numerical columns with this dummy column. So you can see here is my final feature set that I going to pass into the model. So as I mentioned, like I need to pass two kind of inputs. One is that sequence of the past matches, and another is the all that match characteristics column. So here I created a function named create sequence. So what it will return? It will return the performance of the past 15 matches for each of the rows. And here I dividing the training part and the testing and the validation part. So 80% I used in training and remaining 20% as validation. And here is my LSTM network. I just use two layers. So this is a base model. You can add multiple layers also. Okay, I use the loss function as mean squared error and optimizer as add-on. So once the model is trained, you can see that actual versus predicted curve. So you can see like as that prediction is dependent on the past performance also. Like here you can see like as soon as players are getting runs, it is getting higher. And the two thing to notice, one thing is like even it is Virat Kohli is performing against poorly against West Indies, that the graphs are still remain pretty much flat. Okay, because he has maybe past good records against West Indies, so both the prediction and that earlier factors is considered. So that's why that graphs is not tipping anymore. And you can see like even he scored two big runs against Sri Lanka and South Africa, the model is actually predicting deep for the New Zealand, because he has not a good that great record against New Zealand earlier, because Trent Bolt get him out early quite sometimes. Okay, and the recent last match is the World Cup final Australia. You can see it is predict the model predicted around 49, where Kohli scored 54. So you can try with your own players, and you can maybe play with different hyperparameters, different model architecture, and also different sequence length of the past matches. So probably after different trial and error, you can get somehow better model. But as I told, the cricket match data is not consistent. Even you can see that original data, like how much fluctuating it is. So that's why you cannot get that much of strong trend. But anyways, this LSTM performed much better than ANOVA or other time series model. If you run the ANOVA, probably it will just give almost a flat line to you. So that's for the video. I hope you like the video, and if you like it, then please subscribe to my channel. Probably it will motivate me more to make more interesting video like this. So thank you. Goodbye.